Good morning. Today we will going to discuss a data link layer protocol. When it comes to a data link layer, basically there are four protocols that are defined for data link layer. So those four protocols are simple, or sometimes we also call it as a simplex protocol. The second one is stop and wait. Third is go back and. And fourth one is selective repeat. These are the four protocols that are defined that we supposed to discuss in the data link layer. But in our syllabus, we are going to discuss only regarding these two. Now, to understand regarding these protocols, we use FSM. FSM indicates finite state machines. So, an FSM is thought of a machine with a finite number of states. The machine is always in one of the state until some event occurs. Whenever some event occurs, that event will generate some actions. So that event makes a machine to change its state. While machine is moving from one state to another state, certain actions will take place. So machine will make change its state only when event occurs, and that event in turn generates some actions. This is what is an idea of finite state machine. I talk regarding, I'll take one example of FSM in which there are three events which are occurring, which are changing my finite state machines to change states. We'll discuss regarding that. This is a simple example where I have to consider one state as a initial state. So for understanding reason, I'll consider that state 1 as initial state, and when some event occurs, okay, so that makes this machine to change its state. So it changes state from 1 to 2, it moves to a state 2. This action of changing state from one state to another state is because of some event. So here I'll call it as event 1. So this event will generate actions, that is action 1 and action 2. The A indicates action here. So the event will make this machine to change its state. So I assume that state 1 is the initial state. So from this state, whenever it is in this state, whenever the event 1 occurs, machine changes its state by performing a action 1 and action 2. This is the way we represent the actions. So normally we write this particular thing one below the other, like say, rather than writing the action 2 in front of action 1, we write it one below the other. So event, along with it we are representing the actions. So whenever machine is in a state 2, there are, so in this example I am considering the two possible events can occur. So the first possible event is event 2. Whenever event 2 occurs, say I'll assume that some action 1 is performed and the machine will come back to its own original that state 2 itself. So, this is one of the possibility, and whenever event 3 occurs, machine changes its state from 2 to 1, and I will assume that there are no actions performed. So, just to demonstrate that it is not mandatory that every event should generate the actions. So, whenever machine is changing its state, it is not mandatory to perform some actions. Sometimes actions will going to be performed, sometimes no actions will going to be performed. So, to demonstrate that, I have taken the event 3 without any actions. Okay. Whenever event 1 occur, there are 2 actions happening. Whenever event 2 occurs, 1 action is happening, and whenever event 3 is occurring, so there are no actions happening, but it still changes its state from state 2 to state 1. So, this is one simple example of finite state machine. Now, we will try to say represent the FSM of these two protocols. Finite state machine, in short, it is called as FSM. Okay. So, we will try to represent the, or we will try to represent these two protocols in a FSM form. So, before going for FSM representation of the first protocol, that is simple protocol. So, first we will try to understand how exactly a simple protocol works. Once we know the complete working of simple protocol, then it is easy for us to represent that protocol in the form of FSM. So, to start with, I will talk regarding a simple protocol first. Now, as you know, this simple protocol is a data link layer protocol. Its job is to send a packet to the sending side to a receiving side. So, in case of simple protocol, we are assuming certain situations that data link layer, whenever a data link layer gets a packet from the network layer or a message or a input from the network layer, it creates the frame and it sends these frames. We will assume that there are no errors on the channel is error free. This is very much hypothetical situation, but still with this assumption I will start. Okay. So, there are no errors on the this channel, and the receiver is capable to receive whatever sender sends. There is no waiting for a sender. That means sender, at what rate sender generates the packets, at the same rate receiver is capable to consume the packets. So, there is no question of sender overriding or overwhelming the receiver. Okay. So, whenever sender sends a packet, the packet will going to reach the receiver without any errors. That is the first case, first assumption. The second assumption is receiver is capable to consume the packets that comes from the sender. So, that means in this protocol there is no flow control, means the receiver does not bother regarding at what rate the sender is sending. So, at what rate it sends, it is capable to consume it. Okay. There is no flow control and there is no error control. And one more thing in this whole discussion, that the packets or the messages or the inputs at sending side will going to be generated by network layer. So, whenever a network layer is ready with the packets or the data, it will hand it over to the sender. So, whenever sender gets the message from the network layer or the data from the network layer, its job is to create a frame and send the frame. So, generation of frame happens only when it gets a sufficient data from the network layer. At the receiving side, job of receiving data link layer entity is to receive the packet, hand it over to the network layer. So, here it is not even bothered to verify for the errors and all, and it is also very sure that channel is error free and it has say infinite buffer. Even if you assume that it has an infinite buffer, no issue. So, it is capable to consume the packets that are sent by the sender. So, now one thing is clear, So, the sender, the event like arrival of a data from the network layer makes the sending side to change its state by causing some kind of a action. Similarly, at a receiving side, you see the event of arrival of frame will make the machine of receiver to change its state. Okay. So, these two things you keep it in the mind. So, keeping these issues in the mind, we will try to represent a finite state machine of this particular protocol. Now, first I will draw the FSM of sending side. As you know that sender in this protocol, sender will be in a ready state. Okay. So, the initial state of the sender is ready state. Moment in it gets a packet. Okay. So, that is an event. The event is what? Packet comes from the network layer or the data comes from the network layer. Since network layer deals with the packet, so I am using the word packet. Packet come from network layer or arrival of packet. So, whenever a packet arrives from the network layer, this is an event here that you keep it in mind. So, what will going to happen? What actions will going to happen to this? Make a frame. See, once a packet comes, once a packet arrival notification comes, what it will do? It accepts those things, and what it will do? It will make a frame. It converts the data of the packet into a frame and sends it. Okay. So, this is an event and this is an action to this event. So, after performing this action, what happens? Just tell me. It is nothing but again coming back to a ready state. So, once a packet is sent by the sending side, what it has to do? It has to be ready to consume the next message or the next packet that is coming from the network layer. So, that is, these are the actions that are happening at a sending side. So, whenever a packet from this network layer arrives at a data link layer of a sending side, so what it will do? It makes the frame and sends it. So, after sending the frame, again it will be waiting for the data to arrive from the network layer. So, this is what is FSM of sender. Hope it is clear. So, next we will try to represent a FSM of receiver. Now, as I said, what happens a receiver to do the job of, say, transferring the packets to the network layer? So, the arrival of frame. Now, you keep it in your mind that arrival of a frame is an event over here. So, whenever a packet, whenever a frame arrives over here, what it will do? Its job is to accept that frame, deliver the packet to the network layer. So, it has to extract the packet that is present in the frame, hand it over to the network layer. Is it clear? Since here we are not bothered, we are not taking care regarding error and a flow control. We are assuming that my channel is error free. So, that is why the other issues, other events we are not taking into consideration in this example. Okay. So, I will try to represent FSM of receiving side. So, in this case, as you know, the receiver has to be ready, like same as that of sender, because every time it is waiting for packet. As I said, the receiver is not at all slower compared to the sender. Receiver is maintaining its speed at par with sender. So, at what rate sender is sending, the same rate it is consuming the frames. So, this is initial state. So, as you know that to start with, it is in a ready state. So, as I said, frame arrival notification or frame arrived, whatever it may be. The actions what will going to happen? Deliver the packet, to network layer and comes back again in the ready state to accept the next frame. Next, we will try to discuss regarding slightly or more realistic protocol. Okay, so this particular protocol is a stop and wait protocol. So this is a stop and wait protocol. As I said, it is a realistic protocol compared to that of the simple protocol. So in this case, so we are not considering any hypothetical situations. In this case, the sender is sending the packets and receiver is receiving these, sender is sending the frames, receiver is receiving the frames. Before handing over these frames to the higher layer, job of the receiver is to verify for errors. Moment there are, if it notices an error, it will perform some kind of a actions. Okay, so these are the certain situations of stop and wait protocol. So before going for FSM of stop and wait, first we will try to understand how exactly stop and wait works. So as you know that for stop and wait also, the data comes from where? It comes from network layer. Job of say data link layer is to give a services to the network layer. So it has to accept the packets from the network layer. So this is my network entity, this is my data link entity at sending side. So what actions it will perform, we'll see. So I'll try to represent the things on the timeline. Okay, so data that arrives from the network layer, so that data is in the form of a packet here. Packet will be handed over to the data link layer. Now job of a data link layer is to create the frame using those packets. This is my data link layer entity at a receiving side and sends it to the receiver, and this is my network layer entity. Yes, and then as I said, it will verify and hands it to the network layer. Clear? Same, whenever next packet comes, it performs the same action. It will going to be received and it will be handed over. So this is how the stop and wait works. Okay, so now here we are calling it as say stop and wait, because so one thing I have missed over here, that is the acknowledgement. I'll redraw it. Few of the issues I missed in the first explanation, so I have redrawing it and I will just explain it again. So as I said, this is the stop and wait protocol, which is more realistic, and it is the it is not assuming anything. It is talking regarding a realistic channel where there are the possibilities of errors. So as you know, whenever packet comes from the network layer, job of a data link layer is to create the frame, send it. Okay, so it is creating the frame and sending it. So before sending a frame to the next data link layer entity, that is receiving, this is my receiving entity and this is my sending side. So whenever it, before sending the frame, what job it will going to do is it creates one timer. So before sending a frame to the receiving side, first it sets the timer. Now I will just explain you why we need this timer. Now the purpose of this timer is for error control purpose. Okay, now as we discussed this particular thing in the last class, the last video, where I told you that the acknowledgement idea itself will going to be used for to perform two tasks. One is error control, another is flow control. Now to inculcate those two things in our protocol, stop and wait protocol, we are using the idea of say timer, which is helping me to detect the errors that are happening at a receiving side. So moment the frame leaves data link layer, so the frame will going to be the timer will going to be set for that particular frame. Now in this protocol, since I am not sure my receiver at what rate my receiver will going to consume the frames, so for that reason the sender has to wait till the acknowledgement comes from the receiving side. So moment a frame arrives at a data link layer, so the what actions will going to happen? The data link layer first test it for error. There will be some time will going to be spent for verifying of this frame, whether the frame received is correct or not, that is required to be tested. So moment it gets a confirmation regarding the correct arrival of the frame, it will perform the next action. So the next action is hand over this packet to the network layer. So the frame gets converted into a packet, handing it over to the network layer. So simultaneously it will also do the job of sending a acknowledgement. Now the purpose of this timer is waiting for acknowledgement for certain amount of time. Say assume a situation where if acknowledgement does not arrive at a sending side, so if how exactly sender will come to know that the packet is reached the receiver? Now to know regarding this, we are making a sender to wait for a finite amount of time. So normally this time will going to be calculated based on round trip time. So normally sender will going to wait for round trip time. Okay. So moment a frame has been sent, the timer will going to be set for receiving of acknowledgement. So within the stipulated time acknowledgement arrives, then the sender will conclude that the frame sent by it is reached the receiver in the safe state and receiver is consumed it. In case if acknowledgement does not arrives, so I will talk of that situation. Say if I will assume that my first frame has gone in a safer state, and for that acknowledgement has come back to the sender. Now I will talk regarding the second packet. So I will assume that the second packet arrives over here. So sender has sent this packet, and before sending the second packet has arrived, and it converts that to a frame and sends it. Okay. So I will assume that this frame is lost or corrupted or something has happened with this frame, it has not arrived at the receiving side. Now if this particular frame does not arrive at a receiver, how exactly receiver will come to know that sender has sent a packet to it? Yes, since it is not getting any frame from the sending side, what it has to do? It has to wait. Its job is to keep quiet, nothing to do, because since it has not received anything, so it will not going to send an acknowledgement. Okay, frame is lost, so no question of sending an acknowledgement. Now you see the working of timer. You are setting a timer for certain finite amount of time and you are sending the frame. This sender will wait for that finite amount of time. Thereafter, yes, it will do the job of resending of the same frame, because now it is very sure that frame has not reached the receiver. There is something has gone wrong with the frame. So within the stipulated time it has not got acknowledgement, means what it is? It is nothing but the frame has not reached the destination, or even if it has reached the destination, there might be some error. So that is why the receiver has not accepted it. So if receiver is not accepting the frame, it will not going to send an acknowledgement. So if the acknowledgement does not come, sender has to wait for timeout period. We call this waiting period as a timeout period. So moment a timeout occurs, sender will resend the same frame. So here I will call this frame as 2. So it will going to resend the same frame. So that means to send the same frame again, what is needed at a sending side? Before sending any frame, it has to keep a copy of it. So that in such events, say losing of packets or something, in such events it requires to resend the same frame. So that means before getting an acknowledgement, yes, the sender all the time keeps a copy of the sent frame in a buffer. In case if it does not get an acknowledgement, it will do the job of resending. So moment it resends the frame, it will not forget to set the timer. Again it will set a new timer for that particular sent frame. Now I will talk regarding one more situation here. The frame 2 has been sent, timer is set. Now I will assume that this frame has arrived in a proper shape at a receiving side. Yes. So receiver hands over this packet to the higher layer and sends an acknowledgement. So moment it sends an acknowledgement, assume that acknowledgement is lost. This acknowledgement is lost. If acknowledgement is lost means what? Again sender is in a dilemma that this frame has not reached the destination. So here what has happened? Loss of acknowledgement. Frame has reached the properly, but acknowledgement has not come back to the sender. So what sender will do? Again it will do the same action. If acknowledgement does not come within the timeout period, yes, this is my timeout period. So what it will do? It will again resend the same frame, that is your frame 2. Yes. So again timer will going to be set. Now I will assume that it sends back an acknowledgement which is received in the safe state. Now one thing you keep it in mind in all this discussion. So I am talking regarding using of some frame numbers. Okay. So in this example, for understanding reason, I used the numbers 1 and 2. I hope it is clear. So now what should be the actual frame numbers? Basically we call them as a sequence numbers of frame. Okay. What should be the sequence number of frames in stop and wait? What should be the length of sequence number? That is my question. Like say I am sending a frame, you are sending the first frame, you are sending the next frame, you are next again you are once if you get an acknowledgement for frame 2, you are sending the third frame, sender is sending the third frame, again sender is sending the fourth frame once it gets an acknowledgement for third frame, and so on. So this is what is a question. Now the question arises, what should be the length of sequence number? Normally this sequence number will be one of the field of the header. Okay. So as I said in the previous video, header consists of one vital information, that is address. Okay. Sender's sending address as well as receiver's address. Apart from the address, sender also holds some control information. One of the vital information of the header is sequence number. Now question is, how many bit, what should be the length of sequence number? Whether it is a 16 bit, whether it is a 32 bit, or whether it is 10 bits, 5 bits, what it should be. So normally in stop and wait, the length of the sequence number is 1 bit. Just keep it in mind, how many bits? It is 1 bit sequence number. Now naturally question arises, a 1 bit can give you two possible states, that is 0 and 1. So that is enough for us, because moment it sends a frame 0, it gets an acknowledgement for 0. So receiver has to wait for which frame? It has to wait for frame 1, because already it has consumed a frame 0, fine, and it is waiting for next frame. So the next number it is waiting for frame 1. Moment it gets a frame 1, I will change these frame numbers. So what it will do? It has got the frame number 1. So it sends an acknowledgement for frame 1. Okay, normally in a stop and wait protocol, so what they do is they send an acknowledgement number of next frame expected. Acknowledgement will contain the sequence number of next frame expected. So now you see it has consumed a 0, already 0 is gone out of its list. since 0 has arrived properly. Okay. Now see, it is waiting for which frame now? The sender receiver is waiting for frame number 1. It is waiting for frame number 1. So, moment it consumes 0, it is waiting for frame number 1. Moment it gets 1, it will wait for 0. This action repeats. So, to handle a situation of the type stop and wait, we need a sequence number of only 1 bit. So, 1 bit is enough. So, 1 bit can give me a 2 states, 0 or 1. So, because of that, we can very easily handle this situation. So, I will repeat the whole actions again in stop and wait. So, whenever a packet arrives from the network layer at a sending side, data link layer accepts that packet, converts that packet into a frame, sends that frame. Before sending, it will perform 2 actions. One action is saving it in a buffer, saving the copy of the frame in a buffer, and setting the timer for that particular frame. So, before sending any frame, it also gives some sequence number. So, that sequence number length is only 1 bit. So, 1 bit sequence number is enough for sender to send the frame. Now, at receiving side, receiver's job is to wait for continuously, it is waiting for one particular sequence number. Moment any packet arrives out of say context, say for example, in this case frame 1 is received properly, yes, so it is consumed by the network layer. Since the acknowledgement is lost, again the frame with sequence number 1 is arrived at a receiving side. What it will do, whether it will going to consume this frame or what? No. Why? Because moment it consumes the frame 1, it is receiver side will receiving entity will now wait for which frame? Waiting for frame with sequence number 0. That next sequence number is 0. So, it has already sent an acknowledgement saying 0. So, that means it is waiting for frame 0. If any frame comes other than 0, will going to be rejected. It will going to be rejected. It will not going to be consumed again. If it consumes it, it is a duplicate packet. So, what it will do? It will accept it, it rejects the packet, but it still sends an acknowledgement for sender, because now receiver comes to know regarding that why this frame has arrived. So, to clear the confusion of a sender, what it will do? It will send an acknowledgement saying that you send me a frame with sequence number 0. Okay. So, this is how it works. Now, we will try to draw a FSM for this particular protocol. Now, we will start with FSM of stop and wait. Now, you see the initial state here is ready state.